In physics, we use a lot of pictures, diagrams, arrows, vectors, that's what an arrow is, to describe what's happening and what kind of problems we are looking at. So let's figure out what these different free body and dot diagrams are and how to make them. Okay, there are a few ways to draw free body diagrams. There is a picture free body diagram and a dot free body diagram. I like the picture ones because it's a little, you can be a little more creative with them and it's very understandable about what you're looking at. It's just a little harder to draw the actual objects. And a dot free body diagram is just a dot. So it's pretty easy, but for me, I'm very visual, so I like to have pictures. So a picture free body diagram, we did these, oh, we didn't do these yesterday in the lab, but we're going to do them in the next activity called Newton's third law. And dot body diagrams, they are using a dot, of course. So how to draw a dot free body diagram? First, we need to represent the object as a dot. There's the object. Then we need to connect the tail of the force vector to that dot or particle. Boom. Okay, so we've got the dot, we've got a vector. It's showing that a force is heading in that direction. We also need to draw the force vector in the direction that the force is actually acting. So the force is acting in that downward motion. And then you want to draw the arrow a length that corresponds to the size of the force. Okay, then we need to label the vector with a name of the force or an amount for it. So here we're going to say, oh, that's gravity. Okay, so how to draw a dot diagram for this? We've got this weight pulling down on a spring. So the dot is this object, the weight. The spring force, that's a kind of force, is pulling up. Gravity is pulling down. Those are the two forces. Okay, how to draw a picture diagram? Well, that is the picture. So we know it's a spring. We know it's a weight. Gravity is pulling down. We can put the arrow in that direction. And spring force is pulling up. We could put this down along the bottom also. It's not a big deal, just so it's showing that it's going in the opposite direction. Okay, drawing a dot diagram showing this box and this person pushing it. First of all, you start out with a dot and you show the force of gravity pulling down. You show normal force pushing up. Remember the book on the desk? We had the normal force pushing up, gravity pulling down. So here we have the same thing. And then what force? We have an applied force. Means that somebody or something is applying a force. And it's being pushed in that direction, right? Are there any other forces acting upon this box at this moment? Yeah, friction. Friction is pushing it or holding it back, right? So that's what it looks like. We've got these two forces are equal because they're not moving up, they're not moving down, right? That box is not going up or down, but the box is moving to the right. I assume it is. So he's pushing, that applied force is going to be bigger than the friction because it's actually moving in that direction, right? Okay, make this into a picture diagram. That's the first thing you would do. You would draw this picture, which it's already there. And we'd have the normal force pushing up. Gravity is pushing down. His applied force is pushing to the right. And where would the friction force be? I'd put it right there. That's okay. Okay, so again, these two are equal. This one looks like the force is less than the applied force, so that means it's moving in this direction. All right, so now you know a little bit more about what a picture diagram is and what a dot diagram is. You're going to see them a lot during physics. All right, have a wonderful day.